Welcome to Where Are You in Your Multiplication Journey? Let's think about learning about multiplication like a journey. Usually there's a starting point and then there's an end point down the line in any journey. So this is a chance for you to think about what you know about multiplication, and then once you know that, you might have a better idea of what you need to do next in your multiplication journey. The order in which these things are listed here on this paper, I'm going to go through this order starting at number 1 and working slowly down the list. So number 1, and this is the most important part of this entire journey. Number 1 says, I know what multiplication means. Now, how do you know if you know what it means? Well, one way you can answer that question for yourself is, can you do all 4 of these things? A, B, C, and D. So let's go through each one of these individually and talk a little bit about that. Number 1 says, I know what multiplication means. A, I know real life examples of multiplication. So let's say you're trying to think of a real life example of multiplication. Maybe you put your hand in your pocket and you pulled out some change. And it happens to be all nickels. So you've got this many nickels in your pocket. Now this is a real life example of multiplication. Because you might say, wait a minute, each of these nickels is worth 5 cents. How much money do I have? And do I have enough money to buy something I want? So you might say, oh, okay, so there's 6 nickels here, and each one is worth 5 cents. There's 6 nickels, 5 cents each. So we've got 30 cents altogether because 6 times 5 is 30. And you might have said, wait a minute, I didn't think about it that way. I thought about it as, let's just add these up. Let's go 5 plus 5 is 10, plus another 5 is 15, 20, 25, 30. So maybe you added these up by using something called repeated addition. 5, 10, 15, 20, 25, 30. So the way that might look with paper is something like this. 5 plus 5 plus 5 plus 5 plus 5 plus another 5. And when you add these up together, 5, 10, 15, 20, 25, 30. You've got 30 cents. So this is called repeated addition. So one of the ways that you might be able to explain what multiplication means to someone else, you might be able to say, hey, multiplication is just like doing repeated addition. Instead of writing down 5 plus 5 plus 5 plus 5 plus 5 plus 5 equals 30, you might say, well, how many times did I write 5 down? I wrote it down 6 times, right? 1, 2, 3, 4, 5, 6. I wrote 5 down 6 times, so I've got 6 times 5. And that equals 30. These are both exactly the same thing. They say exactly the same thing. One is just using addition and one is using multiplication. They're the exact same idea, just writing it down in different ways. The reason why the multiplication is important to know is because if you had, instead of 6 nickels, what if I had 300 nickels? Well, then I'd have to start doing, if I'm doing repeated addition, I'd have to go 5 plus 5 plus 5 plus 5 plus 5, and I'd have to go on 300 times, probably filling up this whole page. That would take a long time. So if you're using multiplication, it's a lot quicker. And you could say 300 times 5. right? So that's 1,500 cents, which, by the way, is $15. Okay, let's look at more here. So I know some real life examples of multiplication. So that was one. I pulled out some change. Let's do another one for A here. What's another real life example for multiplication? Well, here's another one. Maybe you're playing cards and you've got this. Oh, okay. So maybe you're playing a game of cards and you need to know how much you've got all together here. Sure, you can count by threes. 3, 6, 9, 12. You could count up each of the symbols. I've got 3 hearts, 3 diamonds, 3 clubs, and 3 spades. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Another thing that you can do, so if I was doing repeated addition here, just like the nickels, I'd say 3 plus another 3 plus another 3 plus another 3. I've got 12 altogether. But just like the nickels, you might say, well, how many cards do I have? They all have 3, which is important. They all have to be the same amount. So I've got 4 cards, and each card is worth 3. So 4 times 3 equals 12. Again, both of these say the exact same thing, just using different operations. This is using addition, which is that operation, and this is using multiplication, which is a different operation. I can draw pictures or diagrams to explain multiplication. Okay, so if you can draw a picture, and the other word for picture is a diagram, if you can draw a picture or diagram to explain multiplication to somebody, that's another way that you're showing that you understand what multiplication means. So you might say to yourself, well, I've got some friends coming over. So I've got 3 friends coming over, and I want to give each of my friends a snack. So I'm going to give each person an apple, but I want to give each person some grapes too. So I think I want to give each person 6 grapes. So how many grapes do I need to put in each person's bowl? So each person gets a bowl, right, for a snack. So there might be an apple in the bowl. Forgive my drawing skills. So there's an apple in each bowl, but now we want to give each person 6 grapes. So I might go like this: 1, 2, 3, 4, 5, 6. So that person has 6. 1, 2, 3, 4, 5, 6. That person has 6 grapes. 1, 2, 3, 4, 5, 6. That person has 6 grapes. One way you could figure this out is using repeated addition, just like with the nickels and the cards. 6 plus 6 plus 6 is 18. Another way you could do this is you could say, well, I can multiply. I can say I have 3 bowls and 3 friends as well, because each friend gets a bowl. And I've got 6 grapes in each bowl. And that means that I have 18 grapes all together. Or you could also say in total. If you can draw a picture to explain what multiplication means, that shows that you have an understanding. Something else you might see and need to try and figure out and explain to yourself or somebody else, if you want to try and determine if you understand what multiplication is, you might get this and you have to sort of say to yourself, well, what does this mean? 6 times 4 equals something. What does that mean? Well, in class, when we were at school, and remember, a lot of this we've already talked about for a long time in school, but this is a reminder and also to try and help you figure out where you are in your multiplication journey. Sometimes you can take the times symbol and replace it with these words: groups of. Groups of. So you might say instead of 6 times 4 equals, you could say 6 groups of 4 equals how much? So in that sense, we might say we've got 6 plates. So I'm going to draw 6 plates. I want to try to make this a story now. So I've got 6 plates. And each plate has 4 grapes on it. So each plate has 4 grapes on the plate, because that's our snack. I know it's not a very big snack. Now, the most important thing here is that every plate must have 4 grapes. It can't have more or less than 4. If that's the case, then you cannot multiply. Every plate has to have exactly the same number. So now we've got 6 plates, each with 4 grapes. So how do we figure this out? So this is multiplication because we've got multiples of 4. So that's another way that you can say it. Multiplication, the word multiplication, there's another word inside of that, and it's multiples. You might know what multiples are because you've said the words counting by. So if you know how to count by different numbers, if you know how to count by 5s or count by 10s or count by 2s or count by 4s, you're actually using something called multiples. And that's another way of sort of saying repeated addition. So here we go. 4, 8, 12, 16, 20, 24. I just counted by 4s, right? 4 plus 4 plus another 4 plus 4 plus 4 plus 4. In total, we've got 4 plus 4 plus 4 plus 4 plus 4 plus 4 equals 24 grapes. We've kind of looked at A, B, and C really well. Now we're going to go on to D. I know how multiplication and area are connected. Again, we have done this at school. We spent a fair amount of time looking at area, and we're going to do a quick reminder of that. So here's a grid of centimeter paper. So each of these squares is exactly 1 centimeter. Okay? So let's take something. Let's take one of these playing cards that we had before. Okay? If we wanted to find the area of the card, area means how much space on this paper does this card take up when we lay it down flat? How much space? And if you're saying how much, you're asking how many. How many of these squares get covered up? So I'm going to put this right up to the corner. And I'm going to line up the top edge of the card with that line. And I'm going to line up the side edge. Now, I'm going to do an approximate amount because it doesn't line up perfectly and exactly. And we could find the exact area. But for the purposes of what we're doing here today, I'm just going to make it really close. So I'm going to go like that. So then if I were to outline with a thicker marker the area that this card is taking up, okay. Being careful not to get the marker on the card. Got a little bit on the card. Okay, so that card covers up about that many squares. So in this list, it says, I know what multiplication means because I know how multiplication and area are connected. So this is area. So one thing that you can do here now is you can say, okay, how many squares are here? Let's count up the number of squares inside this rectangle. That's one way to do it. 1, 2, 3, 4. As you can see, this is going to take me quite a while to count up all the squares. And that's okay. If you've got lots of time, that way of figuring out how many squares are in this larger rectangle here, that works out just fine. But if you know about multiplication, multiplication can help you figure out this a lot quicker. So the area of this rectangle here is the length times, there's our times sign, width. So now if we multiply the 9 times 6, we end up with a total of 54 squares in the rectangle, 54 square centimeters. And instead of writing the words square centimeters, which looks like that, that's perfectly fine to write if you want. What I wrote here is the same exact thing, okay? This means square centimeters, a cm, right? cm with a little 2 up here. That means that there's square centimeters. See, these are squares. So one of these squares, that equals 1 square centimeter. Okay. This shows that multiplication is directly related to area. When you're finding the area that something covers up, the flat area, okay, the flat area that something covers up, you are talking about area and you're talking about multiplying the length times the width if it's something like a rectangle. So number 1, as I said, is the most important thing of all of these things. And you really shouldn't go on to anything else unless you're 100% clear about all 4 of these. Do you know what multiplication means? If you do, you know real-life examples. You can explain what multiplication means to someone else. You can draw pictures or diagrams to explain multiplication to yourself and other people. And you know how multiplication and area are connected. So that's number 1. I know what multiplication means. And it's okay if you don't understand it yet. That just means that you're at step 1 somewhere in your multiplication journey. And you need to do more work in order to understand what multiplication means. Let's move on to number 2. I use strategies to multiply single-digit numbers accurately. So what that means is, if you have single-digit numbers that you're multiplying together, you might have something like this. So you can use a strategy. So here's a real-world problem, kind of like we talked about in 1A. So I have 9 friends coming to my party. And I want to give each friend 5 stickers in the loot bag. I found a package of 56 stickers in the store. Is that going to be enough? So in the store, I see a great package of 50 stickers. Okay, here's my drawing of the package. So it might have a big thing on the front, and then it might say there's 50 stickers. And I want to buy that one package of 50 stickers for my loot bag. So how do I figure this out? So the number 2 on the list here in your journey says you can use strategies to multiply single-digit numbers accurately. You will have strategies to figure this out if you have passed through number 1 in your journey. If you can do all 4 things here in number 1, you can figure out single-digit numbers multiplying together, and you can figure these things out using strategies. So for example, one strategy is drawing a picture. So if you have 9 friends, so that would mean 9 different loot bags. So if I draw my 9 loot bags, there's 9 loot bags, and each friend gets 5 stickers in the loot bag. So now I've put 5 stickers in each loot bag, and now I can use another strategy, and that is counting by 5s, or counting in multiples of 5, to figure out how many stickers are in each one. So we've got 5 plus 5 is 10, 15, 20, 25, 30, 35, 40, 45. So 5, 10, 15, 20, 25, 30, 35, 40, 45. So I put 45 stickers in all these bags here by drawing a picture. Remember, drawing a picture is a strategy. Counting by 5s is a strategy. So there are 9 loot bags, and each loot bag will have 5 stickers. There are 45 stickers altogether. Remember, I could say groups of, or in this case, bags of. A bag is a group. So 9 bags of 5 is 45. So this is multiplication. So I've used a strategy to figure out this real life problem that I had when I was trying to figure out stickers and loot bags. Let's move on to number 3 in your multiplication journey. I can skip count starting with any number between 1 and 10. So if you remember, not long before March break, we were looking at skip counting, and we were looking at counting by numbers. We were looking at counting by 3s, and we were also looking at counting by 5s. And these videos are still connected in our Google Classroom, but I put them also in the description below. So the video we were watching for counting by 3s was called 3 is a magic number. And the video for number 5 was called Ready or Not? Here I Come. So each of these is a song. Each of the videos is 3 minutes long, and they really help if you watch them over and over. It really helps to put a song to skip counting. So skip counting is also called counting using multiples. So for counting by 3s, and in this video 3 is a magic number, they group them together into groups of 3. So they say 3, 6, 9, and then 12, 15, 18, and then 21, 24, 27, 30 is the last one. And then counting by 5s and Ready or Not, Here I Come. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So if you can skip count or count by that number, then if you know these really, really well, figuring out multiplication with these numbers becomes much easier. So for example, if you're doing 3 times 5, so 3 times 5, that means you want to skip count one number for each finger for your hand, right? So 3, 6, 9, 12, 15, right? Let's do it again. 3, 6, 9, 12, 15. You don't need to have a piece of paper. Once you can count without writing it down and you know them off by heart, 3, 6, 9, 12, 15, 18, 21, 24, 27. If you wanted to say, what's 3 times 9? I want to put 3 grapes into 9 different bowls. Well, let's get 9 fingers. And we're going to count by 3s using every one of these 9 fingers. 3, 6, 9, 12, 15, 18, 21, 24, 27. So skip counting, can you skip count any number? Now some numbers are a little bit more difficult to skip count by. So for example, 6, 7, 8. These are 3 numbers that are probably the most difficult to skip count by. So learning these will be the hardest of all the numbers to skip count by. But if you can learn them, it will be learning multiplication facts later will be much easier. So that just means you're starting at 6, and each time you're adding 6. And so on. And with 7, same thing. We're counting by 7s. And you keep going. And then 8 as well. And you keep going. So you're counting by these numbers or counting in multiples of those numbers. Same thing. So once you can do those pretty well, once you can skip count with all the numbers between 1 and 10, you are at number 3 on your multiplication journey. So let's move on to number 4. Number 4 says, I know what multiplication facts are, times tables, and why they are important to know. Number 4. So multiplication facts, those are simply these things here. So you might have seen this before. Sometimes multiplication facts are shown in a different way. Sometimes they're shown in a table like this, or sometimes they're shown like this. So let's use this for right now. So this is the collection of all the multiplication facts for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, with every number multiplied by every other number up to 10. So 1 times 1, 1 times 2, 1 times 3, all the way up to 1 times 10. And then 2 times 1, 2 times 2, 2 times 3, all the way up to 2 times 10, and so on. Going all the way up to 10 times 1, 10 times 2, 10 times 3, all the way up to 10 times 10. Okay, so there's a lot of facts there that you can learn. In fact, there's 100 different facts. Now, there's a lot of repeats here too, because sometimes when you learn one fact, like 2 times 5 equals 10, if you go over here to 5, and you go 5 times 2, there it is again, just the numbers are swapped around. So there are some shortcuts later on that you can think about. But this is the multiplication table. And the second part of this is, I know what multiplication facts are. That doesn't mean that you know the answers to them all. It knows that this is the set of multiplication facts, times tables. And here's the next part. Why are they important to know? You should know these by memory eventually. That doesn't mean memorization. There's a difference between saying memorizing these and knowing them by memory. If you know them by memory, it means you've used these enough that you just have them quickly in your head that you can figure them out. But it's important. These are very important to know. And here's the reason. When we start dealing with real-world problems that involve larger numbers, then it's going to be really important to know these basic facts in order to figure out bigger problems. Do you remember the problem of when I was finding out how much soil I was going to need in the garden box? So now we need to multiply these numbers out. So these are pretty big numbers. I could multiply them out. And then I did some big multiplication questions. I couldn't have done those multiplication questions in the video on paper for you unless I already knew these multiplication facts from memory. I knew them by memory because I was really familiar with them. And if I didn't know these, I'd have to figure each one out and it would take a long time. So it's really important later on that once you have found your way down here, and you've done all of these initial steps in your multiplication journey, down here in 6 and 7, that's when we're talking about learning these facts by memory. So let's move on now. Let's go to number 5, where it says, I know strategies, example songs and patterns that will help me learn multiplication facts. So, if you are trying to learn these facts, the best way to learn these facts is making sure, number 1, that you understand all the things that come previously. You know what multiplication means. You know strategies to multiply single-digit numbers. You can skip count all the numbers between 1 and 10. You know that multiplication facts are important. Now you can think about strategies to learn your facts. So I'm not going to go through all the different strategies, but I do want to show you some examples because there's lots of places on the internet, and I'm going to be linking to some of those that give you strategies to help you learn them. So for example, when you're learning the multiplication facts for 5, so here's the 5 times table. So we're talking about the purple one here. If we want to start exploring the 5 times table so that we can learn them and know them really, really quickly, I'm going to write them down. So 1 times 5. So each time we're multiplying a different number between 1 and 10, we're multiplying it by 5. Okay? Now, I could have written this down in another way. I could have said 5 times 1. I could have said 5 times 2, 5 times 3. These are the same things. I'm just writing the numbers down in a different order. So let's write these numbers down. And now one of the strategies is to look for, and we did this as well in class. Remember in the chart paper, we sat as a class and we were looking at counting by different numbers and looking at the patterns that we saw. So look at this really interesting pattern here. If we look at the ones column here, it goes from 5 to 0, 5 to 0, 5 to 0. It's either a 5 or a 0. Do you see that? There's never another number. There's never a 2 or a 7 or anything else. It's always a 5 or a 0. So then we can sort of look at the question here and say, okay, when is it a 5 and when's it a 0? And here's an interesting thing. Every time it's a 0 at the end, there's an even number at the front, like a 2 or a 4 or a 6 or an 8 or a 10. And every time there's a 5 at the in the ones column at the end, there's an odd number, a 3, a 5, a 7, and a 9. There's always an odd number. And here's another pattern that I saw. Okay, so look at, there's a 2 here. 2 times 5. The first number, there's a 1. In this next even one, there's a 4. That's a 2. 6 times 5. If I look at the 6, and then the answer is 30, 6 times 5 is 30, that's a 3. In 8, there's a 4. In 10, there's a 5. Do you see the pattern? Have a look. If it's an even number at the front, okay, say 8 times 5. 8, the half of 8 is 4. If you chop 8 into 2 parts, if you chop it in half, you get a 4. 10, half of 10 is 5. So it's always half. And then there's a 0 at the end because it's an even number. So there's a pattern. So this is a strategy for learning the 5 times tables that will really, really help you. Once you can see a 5 times question, so this next part down here, number 6, I know the easier multiplication facts by memory. And 7 is I know the harder multiplication facts by memory. So the easier multiplication facts, the easier ones are the 1 times table, the 2 times table, the 5 times table, the 10 times table, and the 9 times table. So those are the easier ones. The other ones are the harder ones. They just take a little bit longer. Oftentimes these are easier because for many years you've been learning to skip count by 2s, 5s, and 10s. We started to do that in grade 1. And you might know how to count by 2s, 5s, and 10s all the way up to 100, which is fantastic. If you do, you're way ahead on your multiplication journey because you know how to skip count by those numbers. And if you can skip count by 2s, 5s, and 10s, then you'll be able to get those multiplication facts very quickly. So how do you know if you know the multiplication facts by memory or not? It's if you can figure them out or think of the answer in less than a few seconds. So that means you're not taking time to actually figure them out. If you are, that's fine. It just means that you don't know them by memory yet. So if I said to you, what's 10 times 7? And you went 10 times 7, 10 times 7, 10, 20, 30, 40, 50, 60, 70. I would say, oh, that's great. You know how to figure it out. You're just not at this part of your journey yet. You're still up here at number 5. I know strategies that will help me learn the multiplication facts. So it doesn't mean that, you're not doing well. It just means that you're here on your journey. Counting by 10s to get to 70 for 10 times 7, 10, 20, 30, 40, 50, 60, 70. That's great. You know a strategy, but you don't know it by memory yet. But if I said to you, what's 5 times 9? Oh, that's 45. Oh, okay, well that was within a few seconds, right? What's 2 times 8? Oh, it's 16. You know that really quick. So if you can say it pretty quick like that within a few seconds, that means you know it by memory. So let's say you've finished 6 and 7. So you've looked at the easier and the harder multiplication facts, and you know them by memory. So if you see a harder one like 6 times 7 is 42, you just know it because you have it by memory. Then you're up to number 8 in your multiplication journey. I know how to organize numbers to do multi-digit multiplication. Multi-digit? What in the world does that mean? Well, let's talk about that. Now, by the way, just wanted to point something out here. In your multiplication journey, these ones highlighted in yellow here, this is sort of the grade 3 level, okay? Roughly. The ones here in blue are roughly a grade 4 level. And down here, number 11, grade 5 level. And there's actually more things that you do with multiplication in higher grades, but I've just got the first bit here. So this is roughly the way it works. And you might be, lots of students will be all over at different numbers. I just want to make sure that I just point that out. Roughly, this is grade 3, 4 to 10 are roughly grade 4, and the 11th is grade 5. I know how to organize numbers to do multi-digit multiplication. So let's talk about that for a second. Here's single-digit multiplication. I've been writing them down like this. 4 times 9 equals, so there's a multiplication fact. That's 36. But you can also write this down like this. 4 times 9 equals 36. And it matters how you write it down when you write it down vertically. It matters because you are then thinking about place value. These are the ones, these are the tens, these are the hundreds. And this is really important when you start to get into multiplying larger numbers together. So this is called single digit multiplication because we have a single, which means 1. We have a single digit multiplied by a single digit. Each of these is a digit. Now in multi-digit multiplication, you might have something like this. Maybe you've got 24 times 9 equals something. So now we're into multi-digit. Multiplication. Multi means more than one. So this 24, there's 2 digits in the number 24. That's a bigger number. Yes, 9 is still a single digit, so this is still single digit, but these are multi-digits. So now, we go back to here. I know how to organize numbers to do multi-digit multiplication. So in order to organize this, to do it here, now this is assuming that you, in your journey, you have completed all the way from 1 to 7. So all these 7 steps you've gone on your journey. So you know the easier and the harder multiplication facts by memory. You can recall them in a few seconds. So now, if we want to write this down and organize it in a way that we can multiply it on paper, I'm going to put the 24 there and say 24 times 9. So you'll notice that I have the ones lined up and the tens and the hundreds that aren't there yet. So now I've got 24 times 9. Now I'm ready to multiply. So if I was going to multiply this out, the way this works, and this is now getting into the next step. So this is how to organize the numbers. The next step is I can explain the process to multiply multi-digit numbers together. So here's the process. This 9 at the bottom, I'm going to multiply the 24 by this 9 at the bottom. But I'm not going to do it all at once. I'm going to ignore the 2 for a little bit. I'm going to cover that up, and I'm just going to worry about multiplying the 9 times the 4. So what's 9 times 4? Well, we did that up here. 9 times 4 is 36. But I can't write the whole 36 here. This is kind of like when you're adding numbers together with carrying. I can't write 36, but I can write the 6 because that's the ones of 36. And then I'm going to put the 3 here, because with 36, this is the ones, and this is the tens. So I'm going to put the 6 here, and the 3 up here. I'm going to add that on later. Now, I'm going to ignore the 4, and now I'm going to go like this. I'm going to say 9 times 2. So I'm going to multiply the 9 by this 2 here. So 9 times 2 is 18. And then you add the 3 here from before, the 36. So 9 times 2 is 18. And then 3 more makes 21. So then I put a 2 here and a 1 here. So 24 times 9 is 216. So let's do another one with a 2-digit number multiplied by a 1-digit number. So 37 times 5. So 5 times 7 is 35. I write the 5 here and put a little 3 here to add it later. 5 times 3 is 15. Add 3 more. 18. So 37 times 5 is 185. So with number 10, I know how to multiply multi-digit numbers accurately. When it starts to get more complicated, that's when we have something like this. 2-digit number multiplied by another 2-digit number. So 67 times 49. Now it's really important, remember way back here, number 8, I know how to organize numbers to do multi-digit multiplication. This is organized in the correct way. You can't just go like this and just start multiplying. That's not going to work, because as you're working through your answer, it's not going to be organized and neat. If it's organized and neat, you have your numbers all in their proper places. And that's exactly what they're called, because we have the ones place, the tens place, the hundreds place, the thousands place, and 10,000s and 100,000s, and so on, going that way. So here's what we're going to do. First of all, we're going to ignore the 4, pretend the 4 isn't there, and just multiply 67 times 9. Okay? So 9 times 7, 63. I know it's 63. I have it by memory because I've done that work already. So 9 times 7 is 63. The 3 goes here because that's the ones, and the 6, I'm going to put a little 6 there. So I'm going to add that after. Okay, 6 times 9. 6 times 9 is 54. And now I've got a 6 that I have to add on to 54, which makes 60. So I have to write it like this. Right? Now we're going to ignore the 9, and we're going to multiply the 4. Now we can't, if we're going to ignore the 9 here, that means that we're multiplying by 4. Notice how the 4 is in the tens column? So we're actually multiplying by 40. We've already multiplied by the 9, so now we're multiplying by 40. Now I don't want to have to worry about the whole 40. So in the number 40, there's a 0 at the end. I'm going to put the 0 here so that that's taken care of. So now I can just focus on multiplying by the 4, because I know if I was multiplying 67 times 40, I know it's going to end in a 0. So now I can just ignore that for a little while. And now I can say, what's 4 times 7? That's 28. So put the 8 here and the 2 here. And now 4 times 6 is 24. And then I have to add on that other 2. So 4 times 6 is 24, 26. I'm going to put the 26 here like this. So the reason why there's 2 numbers here, this is 9 times 67. And this second row, this is the 40 times 67. Okay? Because there's the 9 and there's the 4. So we kind of broke it up into 2 parts. Now we have to add these up because we've multiplied this out, and now we need to add 3 plus 0 is 3. 0 plus 8 is 8. 6 plus 6 is 12. And then 1 plus 2 is 3. So 67 times 49 is 3,283. That's the product. So that's multiplying multi-digit numbers accurately. Accurately means you can get the right answer. Okay? And one of the ways that you can help yourself to be accurate and get the right answer is to make sure everything is nicely organized. Once you know how to do this well, you certainly don't need to draw these lines anymore. You can just work it out, but you're able to keep it organized. Sometimes people like to use, get my squared paper back, squared paper to help them organize their numbers. That's great too. Now the number 11, the final thing on our list is I know how to multiply multi-digit numbers with decimals accurately. So this is a grade 5 level, but I will do one of those questions just so that you're aware of how that would work, in case you're already at number 10 in your multiplication journey and you want to see what it would look like with number 11. So when you're multiplying decimals together, you might have something that looks like this. You might have 9.7 times 3.5. You want to multiply those together. So I'm not going to draw all of my lines like I did before. I'm just going to try and do it like this. So the first thing you do is you don't really worry about the decimals. You kind of look at this like it's 97 times 35. So we'll worry about the decimals a little bit later. So 5 times 7 is 35. 5 times 9 is 45, plus 3 is 48. Okay, now put a 0 here. 3 times 7 is 21. 3 times 9 is 27, plus 2 more is 29. Now I'm going to add these up. 5 plus 0 is 5. 8 plus 1 is 9. 4 plus 9 is 13. And 1 plus 2 is 3. Now we're going to worry about the decimals. With addition, you just bring the decimal down and put it here. You do not do that when it's multiplication. Multiplication is a little bit different. So with multiplication, you have to count up the number of decimal digits you have in your original question. So 9.7, there's 1 decimal digit there. And 3.5, there's 1 decimal digit there. That's a total of 2 decimal digits. So then, with your answer will have 2 decimal digits at the end. Some people like to start at the right-hand side and go 1, 2, like this, and then they know where to put the decimal. So 9.7 times 3.5 is 33.95. Let's try one more, in case you're interested. Let's do a bigger question. 67.7 times 4.52. So here's one where the decimals are lined up, okay? And if you were adding these together, it would be really, really important for these decimals to be lined up, okay? So let's make sure that we put a little 0 here. So I'm filling in that empty spot so that we have everything lined up properly. And now we're going to do our multiplication. So 2 times 0 is 0. 2 times 7 is 14. 2 times 7 is 14 again, plus 1 is 15. 2 times 6 is 12, plus 1 is 13. Now we'll go to the next one. So I'm going to put a 0 here. 5 times 0 is 0. 5 times 7 is 35. 5 times 7 is 35, plus the 3 makes 38. 5 times 6 is 30, plus the 3 is 33. Now I'm going to multiply by the 4, but I have to put 2 zeros this time. 4 times 0 is 0. 4 times 7 is 28. Put the 2. 4 times 7 is 28 again, plus 2 is 30. 4 times 6 is 24, plus 3 is 27. We have 3 rows now because we have 3 numbers down here. So now we want to add these all up. And notice how important it is to keep everything organized. This is why, way back here in your multiplication journey, number 8 is super, super important. If you didn't really understand number 8 and how to organize numbers to do multi-digit multiplication, this is going to cause a problem later on when you're trying to do questions with more numbers like this. If numbers aren't lined up right, you might be adding the numbers incorrectly. So let's add these up now. 0, 4, 10. 8 and 8 are 16, 17, 20. 3 plus 3 is 6, 10, 3. Now we have to think about, okay, well, we've got a lot of decimal places here. How many decimal places do we have? Well, we've got a decimal place here. There's 1, 2, 3, 4. So we've got 4 decimal places in our original question. So we need to go 1, 2, 3, 4. So our answer to our question is 306.004. Remember, this is grade 5, maybe even grade 6 level of multiplication. All right? But I just wanted to show, if you are already around level 10 and you're thinking about what's next, you can think about multiplying with decimals if you want to work on that. All right? So what I would like you to do is, in Talk to Mr. Cash, I would like you to, at the very least this week, now that you've watched this video, I would like you to think about yourself and what you know and what you can do. And I'd like you to tell me in Talk to Mr. Cash where you are in your multiplication journey. Just give me a number here. Mr. Cash, I think I'm at number 3. Or Mr. Cash, I'm still at number 1. And I know real life examples, I can explain it, I can draw pictures, but I'm still figuring out how multiplication and area are connected. So I'm at D in number 1. Or you might say, hey, I'm down at number 9. I think I know how to multiply multi-digit numbers together, and I'm just starting to do that. So I'm at 9, working towards 10. So that's what I'd like you to be able to tell me in this week's Talk to Mr. Cash, where you are in your multiplication journey.